we get to a higher class, we will not only be told to find the equation, we will be told to choose the best equation. We will be told to choose the best, which model is the best. And whenever this question comes to you, they will not tell you to do exponential. They will not tell you to do quadratic. They will not tell you to do logarithmic. You have to do all of them and choose the best. And how do you choose the best? The best is the one that has the highest coefficient of determination. We don't even have coefficient of determination here. So because of it, I am going to find it. So I'm going to clear this, and I'll go to my Y1 and clear Y1. And I will actually ask my, go to my mode and say I want 3 decimal places. Even though in exponential, we don't really want to truncate early. So the float is in 3, which means I'll have 3 decimal places. Then the next thing I want to tell my calculator is turn diagnostic on. Whenever I'm doing logarithmic, whenever I'm doing modeling, whether it is exponential, logarithmic, quadratic, whatever, especially when the question says choose the best model, then you need the coefficient of determination, which is r squared, which I'm going to find now. You haven't had this coefficient of determination a lot, is because you probably haven't taken statistics. Okay, but I'm going to say it so that in future, anytime you're told to compare models, you know, actually they're asking you to find the biggest r squared, which is coefficient of determination. Okay, and so I want to turn my diagnostic on. Where do I go? I'll go to catalog. Second 0 is where I see catalog. What am I trying to do? I'm trying to turn diagnostic on. I am going to D because I'm on numerical. Okay, so I'm not in alphabetical. So see diagnostic on. I turn it on. Select on. It says it's done. So I will recalculate. So let me go back and recalculate the equation. My data is still in L1.
It's the same diagnostic that's in, if you go to mode and then you scroll down, it says stat diagnostic.
Yes, yes. If you go to second see catalog, right?
Yeah, there's one in mode, that's the one.
That's only one diagnostic there. Turn it on. So you select that, you hit enter to turn it on. Did you get it?
Yes.
Okay, watch me do it again. Don't give up. Watch me do it again. Bring your calculator, watch me do it.
It's fine, I found it.
Okay. All right. Okay. So now I'm going to do it again. So I'll go back to STAT, arrow to calc, and I'm going to choose exponential regression, which is that 0. And then everything is still the way they are. So I am going to, do you want to store your equation anywhere? Yes, in Y1. So vars, Y-vars, function, Y1. So it's going to store my equation in Y1. And I'm now going to calculate again. And in this calculation, I will have r squared. Now I have r squared, and r squared is 1, which means perfect positive linear correlation. I mean, exponential correlation. So the relationship or the correlation or the coefficient of determination is 1. The model is perfect. So you can now say there is no other model that is better than one is 100%. So it is a perfect model. Exponential is a perfect model. Okay, and now I am going to graph. In other words, the graph I have in my y1 is going to draw in my scatter plot. If I push trace and arrow down, I will see the equation here. And so the equation says y is equal to 5 times 2 to the power x. All right, so now I'm going to go here. The exponential regression is y equal to 5x. Okay, forgive me for that. This is not supposed to be x, so I need to clear that. It should be 5 times 2 to the power x. So the exponential regression, you can use parentheses if you want. The reason why you are using parentheses is to show that it's not 52. It is not 52. That's why you're using a. So A is 5, B is 2, the exponent is x. Okay, so we have done that. Suppose we asked another question. Okay, you know what I'm going to do? This question, I want to answer it from here. Let's go here so that's 5.4. This is a question you will always see in a test. So let's make sure we look at it. In every test, or in almost every test in exponential function and logarithmic function, you are asked to find the percent change. Percent change. What is it? What does percent change mean? So we're going to take time and talk about it now, so it will not be a problem for you. Okay, what in the world is percent change? We did not hear percent change in unit 1. We did not hear percent change in unit 2. Now why are we talking about it? Okay, so if the percent change of the outputs of a set of data is constant means they're almost equal, and we want to find out how to find percent change. And equally spaced inputs. In other words, if the input is equally spaced and percentage change is constant, an exponential function will be perfect. So sometimes you are not given a calculator, and you are not even allowed to do scatter plot exponential function, and you are given a data, and you are told to find percentage change, and use your percentage change to determine if that data is exponential. So that's what we're going to talk about now. If the percent change of the outputs is approximately constant for equally spaced, an exponential function will be approximate. So it could be approximate. So let's go to the next slide. All right, so give this next slide right here. And how do we find the percent change? Step 1, find the first difference. Find the first difference. First difference. What does that mean? What is the distance between 608 minus 780? Find the distance. So what you're doing here is 608 minus 780, and what we are doing here is 475 minus 608. 370 minus 475, and so on. Okay, because it's already done for us, so we're not going to be wasting time and doing that. So, but I want you to know that this first difference is found by this 608 minus 780. 608 minus 780 is 172. 475 minus 608, negative 133, and so on. So second one minus first one. This minus this is that. This minus this is that. We're looking for change, percent change. So the first thing I want you to do if you're looking for percent change is to find the first difference. After finding the first difference, then you find percent change. How do I find percent change? Now look, let me get at my calculator. I'm just going to, if you pay attention, you won't have any, you will not struggle with it anymore. So how do I find the percent change after the first difference? So what I'm going to do is divide the first difference by the number at the right. That means negative 172 divided by this quantity, 780, divided by 780. When I hit enter, I will see that it's negative 0.221, but it said we are told to find percent change. Listen, it says find percent change, because I know that some people, like last year, will write 0.221. The question says find percent change. So change this to percent. That's why it is 22.5, 22.1 here. Also, when you come over here, what you're going to do is, how do I find this number? I will do negative 133 divided by 608, 608. And when I do that, I'll get negative 0.219. Then I will change it to percent. Something happens here, right here, negative 105 divided by 475, you get 0.219. So I just want you to see that the percent changes for all of them are very close to each other. It is 22 point. Each of them is almost 22 points if you round them up. So suppose you round up, you have negative 22%. Therefore, we have almost a constant percent change. I can tell you this is the first time you're hearing this. It is only in exponential function. So how do we find percent change? That's what we just did here. Because this function or this table has a constant percent change or equal percent change, exponential function is the best model. Is that clear? That is one question in the test. On when I go to tomorrow, I will post the practice test. Practice test unit 3. We will start working on it on Friday, and when we go for spring break, you keep working on it. The week after spring break, we will review on Monday, and then we'll take the test on Wednesday of that. So the week after spring break, we review on that Monday. On Wednesday, we take an in-class test, and the test is paper and pen. That's going to be 11 questions again to be done in 1 hour. I want to emphasize that those, if I signed your accommodation, you should go to assessment center and take your test. If you do take your test in class anywhere, I'm not going to give you a retake if you want a retake. So if you want to take it in class, that's fine, which means you will not get your accommodation. You have to go to assessment center to take your unit 3 test. Okay, so let's go to actually the most important thing we came to this section to do is percent change. And we are hearing it for the first time. We better know how to calculate it because it's in the test already. Okay, so let's go to section 1.4. I mean 5.4. 5.5, section 5.5. Okay, and I want you to see it's already here. Let me see where the one has all this is asking you to find the exponential function. Find the exponential function, and so you can do them. That's why I'm not doing another one, because we don't have all the time to do them. Find the exponential function, so you can do this worksheet. This is homework for 5.4. And you can actually be told to do a logarithmic function. If you're told, okay, let's make sure we go to logarithmic. I'm going to clear. Suppose I'm told to put a logarithmic function in the data I have right here. So I'm going to y equals and clear that. And my data is already in y1 and y2. If I'm told to put a logarithmic function there, I'll go to Stats, Calc. If I'm told to model a logarithmic function, I am going to arrow down and start looking for logarithmic. So look at that. Whenever you see lin reg, okay, no, that's not that. I'm looking for logarithmic. Okay, now that is natural. Do you see natural log there? Natural log of, yeah, so that's what it means. Natural log regression. That is logarithmic function. So you select that, but we can go down. So just to know that you have looked. Okay, this is not logarithmic, this is logistic. And sometimes you can see, if you're told to put a sinusoidal function there, suppose if you're told to put a sine, that you're given some function and you're told to do sine, but we're not doing sine, that's 110, but 11, sine, cosine, and tangent. But if you're told to do sine, you go there and put that. All right, and then let's go back to ln, logarithmic regression. I'll select that, which means I'm told to find a logarithmic function on that. And then I am going to go down. I don't have a frequency. I want my equation in y1. So verse, y verse, function y1. And then I'm going to calculate. So let's see what the problem is. All right, I'm going to take that off. See why. Okay, so I go to start again. And I'm going to calculate. And I have lin regression. And I am going to go down. If it happens again, then we're going to do it next time. Okay, so something, the domain. Oh, I know. Okay, let me go to domain. Okay, I see. I need to, let me set my, let my function to minimum. We're not doing sine, I mean. Okay, we're not doing this. We'll do it next time. I need to reset to say my windows are not. Let's do this next time. My windows are not set. Okay. Right, so the next thing we want to go to is, we'll work on that on Friday. So let's go to 5.5. This is 5.4, so I'm going to take that off. I don't want to save anything. Okay, and I am in PowerPoint 5.5. So we still have time. 5.5. Okay, so in this 5.5, we have finances. How do I use the exponential function to calculate the money in the bank? How do I use the exponential function to calculate the money in my bank investment? In this section 5.5, we use investment, continuous compounding, investment, compound interest, annually, semi-annually. I know that this is in Algebra 1, so you probably have had it before, but there are two important formulas we're going to write. So Now, we already know, we're not going to be repeating what we already know. Find the exact quadratic function. So we're not going to do that because we did it in, we did this exact quadratic function that fits 3 points. We did this in unit 2, so we're not repeating what. Model data using quadratic function. Where are we here? Is this here? Oh, okay. I see why it's talking about. I'm sorry. I went to 3.5 instead of 5.5. So I should be in 5.4. Forgive me for that. It should be 5.5. No wonder. No wonder. All right. Okay, so these are what we are supposed to be talking about. Okay, find the future value. So suppose you collected about $10,000 during your birthday, last birthday, and you put it in the bank, and you want to withdraw it after 10 years with 7% interest compounded continuously or compounded annually or 4 times. This section is very, very important. Applications. The applications are very good. Okay, so investments, this is 5.5. Future value of the money I put in the bank today. Okay, so if I'm asking for future value, we have a formula for this. So amount for future time is equal to the principal, the quantity of money I put in today, into 1 plus the rate they give me, APR, over the number of compoundings, maybe 2 times a year, n is 2. Quarterly, it means every 3 months, n is 4. Daily, n is 365. Weekly, n is so whenever you hear compounded daily, it means whenever it's compounded, it's almost exponentially. But compounded continuously means every second, per second per second. We're coming to that. So this formula is for compounded annually, daily, weekly, monthly. Okay, multiply by number of compoundings times time. Amount, future value is equal to the principal, the quantity of money you put in today, into plus, you have 1 plus the rate, the APR, divided by the number of compoundings in a year. And the number of compoundings can be once a year, which is annually, can be 2 times a year, semi-annually. It could be quarterly, 4 times a year. It could be monthly, 12, and is 12. Daily, and is 365, and so on. So you want to go and look at this section, and you can watch the video also. It's very important. Okay, so we're going to be using this formula in this section. This formula right now. Find future value of investment when interest is compounded continuously. Whenever interest is compounded continuously, then we shall be using future value of that amount in the bank is equal to principal e to power RT, because it's continuously, so the base is E, continuous compounding. So whenever the question is compounded continuously, it is this formula. When the question is compounded quarterly, it is this formula. So the most important thing is, do you know the formula to use? If you're given a question that is for continuous compounding,